Hey, what's up everybody? We are back. I am the original gamer StevieStrow. How are you? And this is episode 1, chapter 1, on how to program your TRS-80 Color Computer in BASIC. So we're going to go through chapter 1. There's a total of 34 chapters in this book. How do you talk to a computer? In this book, you'll learn how to talk to your computer. That's all programming is, by the way. Once you learn how to talk to your computer, you can tell it to do whatever you want. Well, almost. We'll introduce basic words in the order that they're easiest to learn. When you get midway in the book, you may forget what a word means. If this happens, simply look it up in your quick reference manual. But what I can tell you is that when I first read these books, I was 14 years old. I had never seen, heard of, or touched a computer before. I was not anywhere good in math or in general academia. I was an average student, but I was able to follow this book and I found it intriguing. There are a total of 34 chapters. We are going to cover chapter 1, which is Meet Your Computer. We're going to go over the print, sound, and CLS commands, which start on page 13 of this book. It looks like there are a total of 34 chapters and somewhere in the neighborhood of 265 pages in this book. Depending on how long these chapters are, we'll try to do at least one episode per chapter. If a chapter is a little bit more in-depth and requires more time, then maybe we will break that chapter up. But I think we can at least cover chapter 1 in this first episode, and then I'm curious to see who sees it, what the feedback is, what do you think of the format? Can you suggest better formats? I'm definitely open to suggestions, and I've never done anything like this before as far as doing a how-to and how to program and trying to squeeze a lot of stuff on a single computer screen. So I'm literally making this up as I go, and I'm sure we will find ways to improve the process as we go through here. So future episodes may look completely different. Who the heck knows? So section 1, the basics. In this section, you'll learn how to program. Before you start, though, put yourself in the right frame of mind. Don't try to do everything the correct way. Don't try to understand everything. Above all, please don't take our word for anything. Sounds like a quote from a movie, right? Don't trust anyone. Do have fun with your color computer. Try out your own ideas. Prove us wrong if you can. Type anything and everything that comes to mind. Ready? Turn the page to begin. So we are now on chapter 1, Meet Your Computer. This chapter and the next introduce you to your computer, the way it thinks, some of its talents, and even a couple of its quirks. By the time you reach chapter 3, you'll be ready to program. Promise. Type whatever you want, press the Enter key. Don't worry about anything but the last line on your screen. It says OK. There's a little side note here that says all letters you type should be black with a green background. If they are reverse, green with a black background, press Shift and 0 keys at the same time. OK is the computer's prompt. It tells you, OK, enough foolishness as soon as you are ready. It patiently waits for your command. You're the master. You tell the computer to do whatever you wish. Okay. Give your computer your first command. Type this exactly as it is below. Print, quote, hi, I am your color computer. I'll switch this over in just a second. So we're going to type in print, space, quote, hi, comma, I'm your color computer, end quote. Let me switch over to the big screen. Print, quote, hi, I'm your color computer, end quote, hit enter. And it printed what I asked it to do. Hi, I'm your color computer. When you reach the right side of the screen, keep typing. The last part of the message appears on your next line. Now check your line. Did you put the quotation marks where we have them? If you made a mistake, no problem. Simply press the back arrow key. So on the color computer, there were actually 4 arrow keys. On our PC keyboards, we have backspace, but they're saying you would have to press the left arrow key to backspace. Your last character, if you type the wrong key, press the backspace key, and the last character you type disappears. Press it again to the next to the last disappears, and so on. So basically they're saying if you make a typo, press backspace or the left arrow to back up. This should be on your screen. First you saw the word OK. Then it said print, hi, I'm your color computer, which you can see here wraps around the screen because it's longer than the characters of the screen. And then when we hit enter, it said, hi, I'm your color computer. Okay. So it's basically saying, if you type this, this is what you should see. And I think that matches, right? So if I go back over here and I make this bigger, we can pretty much see what's on the screen matches what's in the book. Print, quote, hi, I'm your color computer. Enter, and it actually said, hi, I'm your color computer. So that's basically what it's having us do right now. It's telling us to print out something on the screen and telling us what that output should have looked like. What they've just introduced you to is the print command. Basic language is called a language because it has a vocabulary of commands you can type into it, and the various commands command the computer to perform a certain task. One of the most common tasks you will do is to get your computer to display something on your screen, and the command to do that is the command that's called print. When you tell your computer to print, you're telling it to print something on the actual screen of the computer. And in this example here, we put things in quotes, and whenever you put things in quotes, you're telling your computer you are printing out a string of text, and that it's going to not try to process anything in between the quotes. Computer is very literal, and it will often try to process things. So when you've got commas in the middle and you've got numbers in the middle, if there aren't quotes around them, it will try to process them more mathematically. And when you have quotes around them, it says, no, I'm just going to treat this as all a long string of text. So by wrapping the quotes around that statement and then telling it to print it in quotes, it printed exactly what we told it to print. And by the way, there was no spell check on this computer. If you did a typo, there was no red squiggly underline like we have in Microsoft Word. It just wasn't there. So the first thing it told us to do was introducing us to a command called print and telling us and showing us how to print something on the screen. Are there any questions? No? Okay, we're moving on. Your computer just obeyed you by printing the message you have in quotes. Have it print another message. And by the way, everything is followed by the enter command. So now it's saying print space quote 2. Let me go bigger. So it's telling us to print quote 2. Print quote 2. And then hit enter. And what it printed for us is the number 2 that we wrapped in quotes. So by saying print quote 2 quote, it now comes back and it prints the number 2 for us, and it says okay. Now it says try another one, print 2 plus 2. So the command for this is print space quote number 2. I think they have spaces in between there. I'm trying to read white space on a book. I think that was 2 plus 2, but honestly, I can't be sure. And for this example here, it kind of doesn't matter. But it's saying print, quote, 2 plus 2, hit enter. What we will end up seeing, again, is anything that was inside those quotes, which in this case here is 2 plus 2. And it says your computer obeys you by printing out 2 plus 2. And then it says you probably expect much more than an electronic mimic, maybe some answers. Give your computer some numbers without the quotation marks. Type in print 2 plus 2 without quotations. So if I type in print space 2 plus 2, and you'll note now there are no quotes around the 2 plus 2, and I hit enter, what it actually printed for me is the number 4. The computer actually performed a mathematical calculation for me. So the presence or absence of quotes in the print command drastically modifies how the computer interprets that command and what the output of that command will be, or if the command is even a valid command. There are the possibilities to mistype or misrepresent your intentions and get an error. So just to refresh that, if we were to type in print quote 2 plus 2, because there were quotes wrapped around it, it is going to literally print everything that we quoted, and this is known as a string of text. And if I type in print space 2 plus 2 without the quotes around there, it has literally now performed math, and it can do most of your basic math. It can do subtraction, addition, division, multiplication. And so this has just shown us a couple different ways to print, and we had it print numbers as text, and we had it print numbers as a mathematical formula. Now it's basically reiterating the fact that quotation marks obviously have a meaning. Experiment with them some more. Try each of these lines. The first line it wants me to try is to print 5 plus 4. Because there are no quotes, what do you think is going to happen? Is this going to print literally 5 plus 4, or is this going to print the numeric value of 5 plus 4? Anyone? Anyone? You there in the back, sir, with the funny hat. What do you think? Boom. It actually printed 9. So when I say print 5 plus 4 without quotes, we got mathematical. Now it's asking me to print it with quotes. So if I do the same thing and I say print 5 plus 4 in quotations and I hit enter, quotes are going to give me exactly what are inside of them. And it printed 5 plus 4. I think you're seeing a pattern here now. Now it's going to mix things up for us a little bit, and it's kind of, you know, getting a little jiggy with it right now. So now it's saying print space, quote, 5 plus 4 equals, end quote. So this is basically saying print out the letter 5, print out the symbol plus, print out the letter 4, print out space equals, print all that textually. But we're still going. We've ended our quote, but we're now going to continue. And now it's asking me to put 5 plus 4 after that. So I'm printing a portion of this in quotes, and then there's a portion of this after the quotes. And that's the entire statement. And what do you think is going to be showing up in here? I'm going to guess that part of this is going to be literal text, but I'm also thinking part of this might be numeric. Let's hit enter and see what the computer does for us. What it did is it printed the quotational part literally, as we did, and then it also printed a numeric mathematical equation for us that it calculated based on the numbers. What we did here is we used the same numbers inside the quotes as outside the quotes, so the math worked. If I was to type anything wrong, the math would not have worked because it doesn't perform math inside the quotes. So and if I'm not making any sense, okay, so if I say print 5 plus 4 equals, that print 5 plus 4 equals is always going to be inside the quotes because it's a literal thing. But if I went over here and I said print 5 plus 5 instead of 5 plus 4, what we see now is 5 plus 4 equals 10. And even though to a human being that is an incorrect statement, to the computer, it did exactly what we asked it to do. Everything in quotes is a literal interpretation. You said, say this. Dude, I said that. Don't blame me. Don't shoot the messenger. It just so happens the numbers after that are mathematically incorrect. But hopefully this is illustrating the concept that the example it gave us had proper math that matched the quotation marks. But what the computer can do literally could be completely different. I don't know if that helped. I don't know if that didn't or if that made it more confusing. If it did, I apologize. Next one. Okay, now we're doing something without quotes before we do something with quotes. So now it's saying print 6/2, and slash is actually the division sign. So now it's saying print 6 divided 2, 6 divided by 2, space. Now we're going to do in quotes is 6 divided by 2. So the command is basically saying print me out some math and then follow up that math with a literal statement inside quotes, a literal string of text. When I hit enter, what I should see is the number 3, which is the answer to the math problem, followed by the quoted statement. So this answer says 3 is 6 divided by 2. It's a true statement, it matches, but hopefully you realize that the quotation marks here are not going to auto-correct themselves based on the formula you put in there. We're just doing these two things to make a match to make sense. So the next statement is giving us just two examples of the same numbers and same formula, but with and without quotes. So it says to print quote 8 divided by 2 and hit enter. When you do that, you get the actual quoted statement. And then it says print 8 divided by 2 without the quotes, and what we should get here is the mathematical statement. And the answer to that is 4. So the first thing it says is that the computer thinks of quotes as a journalist does. If the number's in quotes, the computer must print it exactly as it appears. If it's not in quotes, the computer can interpret it by adding, subtracting, multiplying, or dividing. And here's another little box of information here. Rules on strings versus numbers. The computer sees everything you type as strings or numbers. If it's in quotes, it's a string. The computer sees it exactly as it is. If it's not in quotes, it's a number. The computer figures it out like a numerical problem. A color calculator, no less. Any arithmetic problem is a snap for the computer. Do some long division. And this is where my head is probably going to start to explode. So print space, quote, 386249, hut, hut, hut. 3862 divided by 13.2 is, quote, space, and then we're going to do the same thing in numbers again. 3862 divided by 13.2, enter. And what it's telling me here is that 3862 divided by 13.2 is 2.92.575758. And honestly, I wouldn't know if that was true or not, and I am not going to try to double check that computer. But we have just told it to tell us in quotes literally what the computer is also going to tell us mathematically, which is just makes this a more user-friendly thing, right? Now let's do a multiplication problem. Print 1589 times 23. And it says that the answer is 36,547. You know what? I believe you. But if not, let's just print one that we can all do in our heads. What if we say print 5 times 5? The answer to that should be 25, right? It is. If I say print 3 times 2, that answer should be 6, right? So when you print numbers followed by the mathematical symbols, it performs the math for you, but there are some differences. So the division is a slash and the multiplication is actually a star, which it points out to us right here. So it says, do the multiplication problem. Notice the computer's multiplication sign is an asterisk rather than the sign that you use in math, which is the letter X. The computer is so precise that it would get the X multiplication sign mixed up with the X alphabetical letter. Here are a few more problems. Just what the world needs. More frickin' math problems. But let's do them. All right. So here's some more math problems. Try a few more. Print, quote, 15. And here's where I think it might make more sense if we do it more literally inside the quotes. Where here it's saying 15 star 2 equals. If we wrote out the word times, 15 times 2 equals. So I'm deviating slightly from the book. So instead of the star, substitute the star for the word times. 15 times 2 equals, end quote, and then we type in 15 times 2. What we should see here is 15 times 2 equals 30. All right, so I'm just kind of modifying the code here just a little bit on the fly. The next one says print 18. 18 times 18 is the square of 18. I'm just going to do what that one says because this is already math that's larger for my brain to handle without the assistance of technology. So 18 times 18 is the square of 18. What does that mean? I don't know. We'll find out here in a second. So 324 is the square of 18. Okay, good for you. And then the last thing it's telling us to do is to do some decimal point division. So if I say print 33.3 divided by 22.82 and hit enter, what we're seeing is the answer to that crazy math is 1.459 blah blah blah. All right, so it's basically showing us here that you can have the computer do math for you. Now it's saying it's your turn. Have we been paying attention? Are we ready to play along at home? What it's asking us to do is to write 2 command lines that will print the problems as well as their answers. So the problems need to look like this. We need to print that part out, which means if we need to print something out literally, it needs to be wrapped in quotes. But then we need the answer to it afterwards, which means that'll be outside quotes. So the problems that they're asking us to print, we will wrap quotes around, and then right outside those quotes, we're going to actually write in the same numbers to actually do the math. Does that make any sense? So it's saying to type in print quote 157 divided by 13.2 equals, and then outside of that we're going to do the same thing, 157 divided by 13.2. So what we'll see here is that the quotes wrapped around this are going to be the literal portion of what actually gets printed, and then the formula outside of there is what's the mathematical thing that's going to be processed by your computer. So in the end, the two things should match up because we're doing the same two things twice. So when I hit enter, I'm seeing the quoted portion here. From this part to this part, this got quoted right under here. So 157 divided by 13.2 equals, now this answer here is the answer to this math problem that was pulled out on us outside of the quotes. So anything that's outside of quotes is considered to be a number. Everything that's inside quotes is considered to be a string. And so the second one it asked us to do was the 95 times 43 equals. So we need to print the problem with the answer. And again, to get things literal, we need to wrap quotes around them. So if we were to type in here, print quote 95 times 43 equals end quote, everything inside these quotes here should be literally interpreted and literally repeated. And then outside of the quotes, we're going to type in the same formula that will now be processed mathematically. And when we hit enter, we should see the question and the answer again, which is what the book asked us to do. And so now we're seeing that 95 times 43 equals 4085. And a computer does not automatically put commas in here as well either. At least these early versions didn't do it in their formulas. So it challenged us to print the questions and the answers by applying our understanding of wrapping quotes around things to provide literal strings of text. In the great analogy that the book gave us is good, like a journalist, right? A journalist is going to quote what they hear, what they read, what they see. The computer is going to quote what you put in quotes. That's a great analogy there. So, and it said if you use the correct commands, this is what you should see. You should see that 157 divided by 3.2 equals 11.83, blah, blah, blah. And you should see that 95 times 43 equals 4085. So the book is basically telling us this is what you should see, and then the book even says this is what you should have typed, and it lets you know. So I hope you've seen so far that this book does a really good job of explaining things. And I'm telling you, I said it before, I'll say it again, I was a kid and computers were brand new. We had no previous experience with computers. So this was all new to us. And I was also a kid who was not very good in math. And now I'm an adult who's not very good in math. But you don't have to be a rocket scientist to learn some of this stuff. It does start to make sense. It is very logical and it does make sense over time. And so now it says it has rules. By now the computer has probably printed some funny little messages on your screen. If it hasn't, type in this line deliberately misspelling the word print. So it is telling me to type in PRINT space quote hi. It's saying print the word, type in the word print incorrectly. When I do that, I just got a question mark SN error. I saw these quite frequently as I was learning to program. So it's saying right here what we just saw, that the computer prints question mark SN error. SN error stands for syntax error. This is the computer's way of saying the command PRINT is not in my vocabulary. I have no earthly idea what you want me to do. And anytime you get an SN error or syntax error, you probably made some type of typographical mistake. So SN error was an abbreviation for syntax error. Everything a computer does is considered to be within its syntax or its language or the format or flow it expects to interpret everything. There is a flow to how things need to be spaced. Some things can be crammed together. Other things need a little breathing space. So understanding that flow will come over time. The computer also gives you an error message when it does not understand what you want it to do, but it feels you're asking it to do something that is illogical or impossible. For instance, try this. Try to print 5 divided by 0, 5/0. So if I say print 5/0 or 5 divided by 0, I got a question mark /0 answer. What does that mean? The computer prints out question mark /0. That means, don't ask me to divide by 0. That's impossible. For God's sakes, Jim, I'm a computer, not an impossibility. What does that mean? I don't even know. All right. So, but basically, the illegal division by 0 request. You cannot divide by 0. So, warning, danger, Will Robinson. So if you get an error message you don't understand, flip to the appendix. We've listed all the error messages there and what probably caused them. And now it says it's a show off too. So far you've seen your computer, all you've seen your computer do is silently print on a green screen. But your computer enjoys showing off. Type in, all right, so it says type in CLS'3. And boom, we have a blue screen with a green line at the top. And it even says that right here in the book. Now your screen is a pretty shade of blue with a green stripe at the top. Your command told the computer to clear the screen and print the color number 3, which just happens to be blue. It says here in the little sidebar note too, if you don't get the right colors, refer to the color test in introducing your color computer too. But why the green stripe? Great question. Why the green stripe? Inquiring minds want to know. Whenever the computer prints characters, it must use a green background, not a blue background. Type some more characters. The computer uses a green background for them also. I am typing characters. Yes. So as you type, the computer automatically replaces whatever color was there with the green background for the characters. Colors other than green are for printing pictures. You learn how to do that later. Press enter at the OK prompt and type in CLS7. So it says type in CLS'7 and it says your screen is magenta, which is a pinkish purple with a green stripe at the top. Try some more colors. Use any number from 0 to 8. The color computer has 9 colors. Each color has a numeric code. So all right, let's try CLS0, that is black. CLS1, that is green. CLS2, that is yellow. CLS4, that is red. CLS5 is white with what they call buff. CLS6 is a kind of greenish kind of color. Teal, I don't know what they call that. CLS7 is the purplish color. Is there an 8? CLS8 is a kind of a pink peachy color. Is there a CLS9? There is not. Now it says Microsoft. So we have black for 0, green for 1, yellow for 3, red for 4, white for 5, a weird green for 6, a purplish magenta for 7, and a peachy orangey color for 8. So there are our 8 colors. And if you said type in CLS without a number code and you just type in CLS, it assumes you simply want a clear green screen, because we all do that, don't we? Now it's saying sound off 1, 2. We're now going to introduce you in how to generate sound with your computer. So the command it wants me to type is sound space 1, comma 100. So it's saying sound 1, comma 100. Hit enter. Okay, so I heard a very low frequency tone for a fairly lengthy period of time. If you don't hear anything, turn up the volume and try it again. What you're hearing is 6 seconds of the lowest tone your computer can hum. How about the highest tone? Type in sound 255, 100, and we'll hit enter. Make it stop! That was really high pitched. I think dogs are running to my backyard right now. Okay, so we just heard the lowest tone and the highest tone, and it's saying that that lasted for 6 seconds. Okay, so it has a good hum range. Hope you're suitably impressed. Try some other numbers. Hope you like your computer's voice. It's the only one it has. You want to know what the other number is for? Or maybe you've already found out. The second number tells the computer how long to hum the tone. You can try any number from 1 to 255. Try 1. So try to command sound number 128, 1. So what I'm seeing here is the first number is the tone. The lower the number, the lower the frequency of the tone. The higher the number, the higher the frequency. The second number is the length. Small number, short length. Big number, long length. So if I say sound 128, 1, that's going to be a very brief, short sound. Yep, boop, real short sound. And now it says that was for 6/100ths of a second. Try 10 seconds. So if I type in sound 128, 10, or it says try 10. Didn't say 10 seconds. Sound 128, 10. Okay, a little bit longer. The computer sounds the tone for 6/10 of a second. Try variations of both numbers, but keep the range from 1 to 255. So if I did sound 100, 5, sound 150, 10. Right, so the first number is the pitch. The higher the number, the higher the pitch. The lower the number, the lower the pitch. The second number is the length. The higher the number, the higher the length. The lower the number, the lower the length. So if I did the lowest sound, which is 1, I could go up to a length of 255, which would be very long. I'm not going to do that. The first time it did it was for 100. Let's just do 50, right? So sound 1, 50. You hear that? That's a longer tone, right? If I do sound 1, 10, that's a shorter tone. So that second number, the first number determines the pitch of the tone. The second number determines the length of the tone. I've said that a few times. I'm sorry. Okay, so that's what they've just showed me. It says, all right, if you get an FC error message, you're using a number other than 1 through 255. FC meant illegal function call. So if I typed in sound 0, 0, FC, man, no, FU. FC, FU. No. So what that means is FC is a function call error. I've performed an illegal function call if I tried to sound 1, 256. That's too long as well. So that's what that little bug down there was saying. If you're using numbers outside the range, it'll tell you. And that's different from a syntax error, because a syntax error basically says, I have no idea what you just said. No hable de whatever you said. But a function call error says you tried something correctly, but you are trying to go outside of an acceptable range of what we are able of doing. So that's a slight difference between an SN error and an FC error. So just to refresh and reiterate and hopefully summarize how the sound command worked, when you typed in sound, let me make this bigger. When you typed in the sound command, the first number here, this number was the tone. So the format is sound, tone, length. LENGTH, right? That's kind of the plain English version of this. Tone, length. And tone is basically a number between 1 and 255. And length is a number between 1 and 255. So that is that's the format or the syntax. The lower the number, the lower the tone. The lower the higher the number, the higher the tone. Same thing with length. The shorter the length, the shorter the shorter the sound, the longer the length, the longer the sound. And so if you wanted to do something right in the middle, 128, 128. 128 is the exact middle between 1 and 256, right? So 128 is dead center. So this is a dead center tone, and this is a dead center length. And I don't know how long this is going to run, but let's take a listen. Oops, I had the word tone in there still. Sound 128, 128. Computer's unforgiving. It didn't realize that I meant to do what I wanted to do, but it didn't do what I meant to do, right? So it's like, dude, I don't know what you just said. No habla de what you just said. So now I'm saying sound 128, 128. Let's see what it sounds like and how long that's going to go for. Wow, that was amazing. That's changed my life. Yes. So that is the most basic of commands, sound, the basic of sound commands. And in standard color basic, that was your only sound command. That was the only thing you had to do to generate sound. In extended color basic, we will learn about other things like play, which is more musically accurate, or sound is very numeric. But there you have it. So because we're using Windows, this is not going to work, at least with this emulator. Okay, with this emulator, you can't do Shift 0. On the original Color Computer, you could. So if you're doing this on the PC, you're going to have to do caps lock. So where it says press Shift 0, if we type in caps locks, this is the inverted characters. And this is how the computer actually displayed lowercase, was green on black. Uppercase, which everything was uppercase, it was black on green, and lowercase, which we'll get to by hitting caps lock, is green on black. So what it's telling me to do here is hit Shift 0. What we now know is that we actually need to use the caps lock key on our PCs, holding both down at the same time, and now you will see some green on a black background. If not, try again. Be sure to hold down both keys at the same time and release them. Now, with the colors reversed, press enter and type in this simple command. What it's actually asking us to do right now is to try to type in commands in lowercase. So if I say print, quote, hi, quote, we're going to get a syntax error because the basic language on this system was case aware or case sensitive, and it actually didn't understand lowercase. It was a case-sensitive language, and it only spoke uppercase. So you could not talk to the computer in its native language in lowercase. That was not an option. Now, just to put to example, one of the things that we learned, though, if I, see right now we're in lowercase, if I hit caps lock and I go back to uppercase, if I put quotes around here and then I hit caps lock and type in this is lowercase and end quote, take it off of caps lock. If I did it that way and I put it in quotes, the computer, like a journalist, the computer will print everything that we tell it to print inside the quotes. However, the commands we give the computer must be in uppercase, cannot be in lowercase. And what it's basically now also telling us is that the commands that we have learned in chapter 1 are the commands print, the command sound, and the command CLS. The keyboard characters that we've learned were the backspace key, which on a Windows PC is going to be the actual backspace key. On a real color computer, it was the left arrow key. We've learned how to use enter on our keyboard, and the concepts we were introduced to were strings versus numbers, as well as a couple of error messages. And the main difference about a string is this. If I say print quote, this is a string, it's going to print that. If I type that without quotes, it's going to try to do math. And because it's going to think these are variables and these variables have not been defined, it's probably going to either print 0 or it's going to say, I don't know what the heck you're trying to do here, dude. It actually printed 0. So without putting quotes around it, it's going to try to do math on what you've done. If you put quotes around it, it is actually going to do it literally. So it also says a refresher like this is at the end of each chapter to help make sure you didn't miss anything. And it looks like that is the end of chapter 1. That was 18 pages of non-stop programming excitement, and I hope you enjoyed that. So we have covered chapter 1. We have learned 3 commands. We have learned the print command. We have learned the sound command. We have learned the CLS command. And to just summarize those a little bit more graphically, if I may be so inclined. So I'm going to use the computer to demonstrate what I'm saying here. So when we print things in quotes are strings. So when we print things in quotes, those are strings. If we print numbers, that's math. So when I say print 5 times 5, that's a math. The sound command will start by generating a tone between 1 and 255, then specified by the length of that tone, which is between 1 and 255. So 1 being the lowest value. So if I say sound 1, that's the lowest tone, and then the lowest length, right? So that's low tone. If I said sound 255 times 1, that's a high tone. The 1 meant very short. 10 would be longer, 100 would be longer, 255 would be the longest. CLS was a way to clear the screen, and we have CLS 0, we have CLS 1, we have CLS 2, which is yeller, CLS 3, blue, CLS 4, red, CLS 5, buff, CLS 6, I don't know, that looks like a weird green to me. I know there's a real name for it and it's in the book, I just don't remember. CLS 7 is magenta, CLS 8 is orange. And it reviewed all those for us. The other things it reviewed were the backspace keys. So, and actually as I'm typing this on my PC, if I do press my left arrow key, it does backspace. And then the other key it showed us was the enter key. So that's what we learned in chapter 1, folks. This was probably a little bit long-winded. I need a deep breath after that. I need a beer after this, actually. Anybody got a cold beer? I need probably 2. All right, so we just finished chapter 1 on programming with standard color basic. We learned some very, very basic things. We typed some of these commands into the computer, and we got an immediate feedback on what these commands do. It's a great book. I learned a lot from this book, and I was able to learn it and then kind of own it and take it off and make it my own and do things with it. And I'm hoping that we'll all be able to do that as we go through here. So I'm going to end this by using my basic commands here and say a few things. I'm going to say print, thank you for watching. It did that. I'm going to say print, please subscribe. Print, leave a like. Print, throw a comment. Print, see you next time. Boom. So there we go. I just had my computer print out. Thank you for watching. Please subscribe, leave a like, throw out a comment. See you next time. So let me know what you think of this. I'm not sure how people are going to like this. I honestly don't know, but we'll find out. So thank you all for watching. I will see you all next time. Thank you. Bye-bye.